Я готов вам представить следующего докладчика. Я познакомился с этим докладчиком полгода назад в Минске. И, честно говоря, я никогда не думал, что он прилетит к нам. Но так как мы познакомились на автопати, то после непродолжительного разговора Мартин в какой-то момент согласился, а на утро уже понял, что отвязываться и говорить, что он не прилетит, бесполезно, и поэтому он прилетел. Я видел его презентацию в Минске на FD-Conf, и именно тогда я понял, что он просто обязан приехать к нам. А потом нашел удачный момент, и, в общем-то, Мартин здесь. Давайте поприветствуем его. Мартин Клеппе. Он прилетел из Гамбурга. Мартин, you are welcome.
Thank you, Oleg, and thanks for having me. I don't know what he was talking about me. You were laughing, not sure. I hope it was good. So I'm really happy. I heard Minsk, so we met in Minsk before. It's like half a year ago, something like this, and I'm quite happy to be here in Russia. It's for the first time, which is super cool. And it's a bit hard for me to like browse the city because I'm not used to this Cyrillic alphabet, and it's not true because like 25 years ago I had some lessons in Russian, and it was like the 6th and the 7th grade, and the only thing that I can remember is Меня зовут Martin Kleppe and я люблю смотреть телевизор. So this was like that's what I remember. There's some other words popping up, and yeah, I hope I will at least say spasibo and things like this. And it was nice when I read through the list of speakers that I saw Leonie's talk, and I always try to find some inspiration for a new project. So I'm going to show something new. And I came across these break characters, and this is also something that we are not used to. So not sure if who can read this. I know at least like one guy here, not sure if someone else. And it's really hard to read it in a visual way. You can use your fingers maybe, Leonie? No, you can? Okay. And this will be about like how to have different views on what we're doing on our daily job and when using scripting languages or like any kind of stuff. But before we get started, I just want to say what I'm doing usually. So I'm one of the organizers, or I'm the organizer of HHS. This is a Hamburg-based JavaScript user group that meets like every month. Andre was there like a month ago, something like this, or something like this. If you're around, make sure to ping me so we will set something up. There's also a conference called JS Unconf. So this is like the cheap version for JSConf, so it's only 60 euros something, and like everyone is invited to give a speech and or to give a talk. So there are maybe like 300 people coming together on one day. You suggest a talk, and then everyone is voting for a talk. So it's more like a community thing that happens on site and on time. I have my own company. I founded it with some friends, 4 founders. We are now 30 people working on web projects, and our main client, I can't say it because it's like the one with the big G, and we are in the office here at Yandex, so it's someone from the US. But we're working with the Maps team quite a lot, and we are doing like all kind of different projects. So we are doing big data analysis or like large data analysis for geographical data. We try to animate it for different visualizations. We do interactive tools, and it's like most of them is like all web-based stuff. And to give you an impression of the scale that we're working on is like, this was something we did in the Times Square in New York. So this was the biggest screen on the Northern Hemisphere, I think. They set it up on the Times Square last December, and we did a project with the Google Maps, with the Google Data Arts team to have some animated maps on there. So this was really huge. I think it was 10K times 5K, something like this, so 50K resolution. But usually we develop stuff for the browser. So this is like what you do and what we do. That's the size what we usually think in. But we also do stuff for mobile. And what I tried to say it's like this talk will be about different kind of scales. So big scale, small scale, and really tiny scale. But I'm not going to talk about my day job, and we'll tell you like what cool projects we're doing, but try to do something completely different. So it will be a fun talk for sure to wake you up after the lunch, and I'm going to tell you, I'm going to show you how I do stuff at night. So I'm sitting like after work at home and think about new projects and try to create something that has no pressures from pressure from outside. No clients are involved. It's like only things that I want to do. I have a website. It's called M1K. You can find me on Twitter at MK. And the topic I'm going to talk about is creative coding. So creative coding is like a way of programming in a more creative way. So you do projects for your own, and I'm going to show you some examples how this will look like. It's also another term, it's called code golf. So code golfing, not sure if you know it, but it's like a kind of competition where you try to solve problems in a really short way, so with the least amount of characters. To give you an example, this code here is about like 380 bytes, and it's, as you see, it's HTML and some JavaScript. And the idea here was, or the question here was, how much space or how many characters or bytes do we need to write Pac-Man in the browser? And this was like the final thing that came out. And it's a bit different from the visual aspects than the original game. It looks like this, so it's only ASCII characters. You see that like this, these hashes, these are the words, the dots are the coins that you collect, the X is the Pac-Man, and the O is the ghost. And once you open it in a browser, you see that the ghost will start to move, and you can use your keyboard controls to like move the X, you move the Pac-Man, you collect the coins, and try to avoid the ghost, and once you hit him, it's over. So that's the idea, and you see there's not that much that you need to like create a kind of copy or clone of the game that focuses on like a minimal aspect of this. So I was involved in this. I didn't do the main logic. I just get something that was there already, which was like K or 2Ks, and try to like minimize it. And I also have some other projects going on. This one is maybe something I got more famous for. So it's a source code of a program. You see a script tag opening and closing, and in between there's just some code. And in the code you have like a hole, and in this hole there's like the shape of the Earth, of the globe. And once you open this, you would see the exact same output as the source code. So this is something called Quine. And if you open it in a browser, it looks like this. So you have color-coded or color-formatted source code, and you have like a spinning globe in the middle. And the whole thing is exactly 1K of JavaScript and HTML. Another project I did is Mandel code. So this is like the shape of a fractal. And once you open it on a browser, you see the output, and once you click it, it zooms in. So it will render an animated version of a Mandelbrot, also with ASCII art. And it was quite a cool project because I had to figure out like some limits of JavaScript. Because when you watch this for some time, after like 2 minutes, you reach a point where the resolution of the JavaScript numbers is not high enough. You know, the floating point is not as accurate, so you see things are breaking apart. Not sure if I should wait some second. I think now you see some jittering going on, and this is like the maximum resolution that you can get. And then that's it. Yeah. Another project I did is jsfuck.com. You might have heard about this. I'm sorry for this rude naming, but it's related to brainfuck, which was a kind of programming language that used only 8 different characters. And there was a discussion on some forums, JavaScript forums or security forums, how many characters are needed in JavaScript to write like any code that you like. And it came up, or it turned out that you only need this bracket, a plus sign, square brackets, or its parentheses, plus sign, square brackets, and an ampersand. And that's all you need to execute any kind of code that you like. I'm going to explain you how it will work, how it works in a second. But to give you an impression, so I set up a website where you can type in your code, for example, allot1, and it will outputs some new JavaScript code that you can copy and paste into your console or into your project, and you don't need a transpiler or anything. It will just execute. So this is the output that you get then for allot1. It's a bit messy, but yeah, it's good. I started the thing, so this project evolves over time to some really crazy aspects that I haven't thought about when doing this before. But it turns out that when you're trying to replace some brackets and other characters here and store them into variables, you can do other crazy stuff. And a project I did maybe like 2 years ago was writing JavaScript with Cyrillic characters only. And this was the first thing I did. So it's like a Russian star. And it has the shape, so it's HTML. And it's valid HTML, not valid, but it works in the browser. So once you open up the page, you see something going on. But it doesn't use any Latin characters, only using Cyrillic and symbols. And to explain you what's going on, so here's something hidden, it's the body unload. And in there, you have some script going on. And once you execute it, you see that there's this little star in the middle. So you have like a pop-up of an alert that will show you this. Yeah. The same thing can apply to like different writing systems. I had some fun doing this, so writing JavaScript from right to left. So using Hebrew, once you type it into the editor, some are still writing it from left to right, but some will output it in the correct direction. So you have to read it from the other way. So this is like the Aleph is equals to an empty string, and then you have the next characters from the other side. And it will also just alert you something. And the same thing could be done in Japanese characters. So this is katakana, and it looks like it's written from up to down, but I use spaces to make it look like this. So you still have to read it like as you're used to, but it gives you an impression that you can write things with different characters. And again, this doesn't need any transpiler, anything is needed. You just have to copy and paste it to your production code and it will give you an alert. Yeah. These were really simple examples. So this was just a proof of concept, how to use different writing systems. But the output or like the logic was really limited. It was always like allot1, allot, and character, and so on. So I was invited to JSConf Asia last year, I think. So I thought, okay, let's do something Asian related with more output, more visual compelling. And I got some inspiration from everywhere, and this time I choose a favorite movie. And the output that you will see looks like the matrix intro sequence. So you see like characters floating from top to bottom. They are highlighted, and you would see, and it will reveal some source code over here. And if you really look close, then you see in the top, you see some Latin characters. And if I stop this, you see that the output, it's the source code itself. So you have a script tag that's opening and closing, and in between you have hiragana, so these are Japanese characters, and a big block of like Asian characters. Not Asian character, but these are kanjis that are usually used in Chinese, but also like in Japan. And maybe to explain you how this works, I have to talk about this, how to write JavaScript without Latin characters. So this is like the main question and the main hack I'm going to do here. And there are two ways to do it. One would be to use escape sequences. And the other one is to play Scrabble, as I would call it. You would see what this is in a second, but let's focus on escape sequences. This, I think it's quite easy. So you might have heard about that whenever you put, for example, character A in the source code in JavaScript, then you can also use a Unicode escape sequence to do this. So instead of writing A, you can say \u and then the 4-digit hexadecimal like representation of it. And you can combine these and do something like this. And this is also like valid JavaScript. And when you look behind the ASCII codes here, it's like alert1. So this will still execute. The cool thing is that you can also use higher ASCII symbols, so or not higher ASCII symbols, or higher Unicode characters. This, for example, the rain character, and yeah, use like other characters here. Another way of encoding or escaping characters is to use hex escaping, and here use a \x and use the hexadecimal representation, but you only can use this inside of code. So it's not possible to write this directly in the source code, but like when you write strings, then you are able to do this. And you're limited to ASCII characters, so you can't write hexadecimal Unicode symbols. Sorry. I was like looking into this kind of stuff and found out, okay, there's still this access needed, or this use needed to write this escape sequences. But there's another one. I haven't heard about this before, but like when you really have this studies on that, you know there's also an octal escaping. So you just have to use a \, and then you can use the digits from 0 to 7 to have an octal representation of the ASCII code. Again, this also works only for ASCII characters. But it's cool, because now you can like replace letters by \ and numbers only. And one thing that you can do is write this. I'm going to explain. So what you see here is like a lot of octal escape things going on. And if you replace them, you see this kind of code. And if you put this in one line, then the code would be square brackets, map constructor, alert1, and some brackets. And to explain you what's going on, if you have an empty area or an array and access map, then this is basically a function. So this is a function. It could also be like filter or whatever, but yeah, we use map because it's quite short. And if you get the constructor of the function, then you get the function constructor, which is quite interesting because it's another way of it's a nice way of like creating functions on the fly. Because what you can do here is you can pass code as a string and also pass arguments, which we don't need here, but you can pass code. And basically, this is an eval. So it's a nice way of like hiding things behind some like invisible, not invisible, but like escaped characters. So this is one way to do it. Another way would be to play Scrabble. This is like a more fun way to do it, and it's highly related to the JSFAQ project. So to explain you the basic concepts, if you have an empty array and you say not an empty array, you get false in JavaScript. And if you say not false, so not an empty array, this is true. It's quite simple. If you then add an empty string to it, then you get the string false and the string true. And what's quite cool is that then you can get like different characters from this. So for example, I get the T, it's the first character, the R is the second, and so on. And you can combine these characters and like add them together and pass them to the eval function that we saw before. So for example, you can get, it's zero-based, so it's the second character of false, the third of false, the fourth of true, the second of true, and the first of true. And if you align this a bit, then you see it's again alert. So you can, yeah, thanks. you can like combine character, and that's why I call it Scrabble. So Scrabble would be possible too. It's not you don't have like every character, but you have things like false, object, true. There's also undefined. Not sure if I'm missing something, but these are the basic types that you can get, and you can like combine the characters that are in there. And the most important thing is it's possible to get the constructor out of this, so the string constructor, because then you can combine it again and write it like as we've seen before. Yeah. So we can now pass or use this as a basis and pass any kind of code as like a string that was concatenated by this crazy like aspects here. So I thought about like different kind of like minifying code, expanding codes, writing code in like 1K in 140 bytes, so it fits into it still works. Sorry, there's nothing on the slide, just to say it, because I thought about the next step, and the next step for me would be, okay, now that I have really short code and can write code in 6 different characters only, how to do invisible code, so code that you can't see. And there's a project on my website. I'm going to post like the presentation and some of the links. This is a recent project. It's called Project Zero. And if you open this up in the browser, you see this. So this is, I think, 78 characters wide. So it fits in one line of your default editor. And once you open this in the browser, you see something crazy going on. So you see some patterns moving. I'm not sure if you know this, but this is like the game of life. So it should be clear. And the source code, it does something tricky, because there's one place, and it's the escape sequence here, escape method, and it holds an empty string. But this string is not empty, because there's something in there. And if you use a hex editor, you would see, okay, there are some things going on. I think, okay, that's too fast. Go back. Something is a bit slow. Let me use the cursors. No. The screen is gone. No, here it is, back again. Okay, so this is like the hexadecimal codes that you can see when you use a hex editor. And the source code, when you translate this, I'm going to explain how it was done, is this. So this is like the unhidden code. And this is like the whole thing. It's 215 bytes that you need to like simulate browser, simulate life in the browser. So what you saw before. How was it done? I looked up the basic algorithm for the convex game of life on Wikipedia, and it has several rules. And the rules are quite simple. So there's a rule for every dead cell that has three neighbors. It becomes alive. And there's some more rules for living cells. So a live cell with 2 or 3 lives on, but if it has fewer than 2, it dies as if caused by underpopulation, and if it has more than 3 neighbors, then it dies as if by overcrowding. So this is like a basic rule, and you always take like one state compared to the previous state, and then decide on what's going on. And this will result in some interesting patterns. So this is quite simple pattern. It's a static pattern. So you see it's kind of square. So 4 cells with neighbors, and all of the cells have 3 neighbors. So it's constant. You also have like patterns that are changing over time. And you will see there are 2 of the cells that are having like 2 neighbors, they are constant, but the ones with 1 and 4, they are changing. So they are flipping. And some more interesting pattern looks like this. So this is something that moves across the screen. And you have like things that can move vertical, diagonal, and like in any direction. And if you take the description of the algorithm and just write it in JavaScript, then it would look like this. And this is like maybe something, this is something to explain how usually code golfing works. So code golfing is trying to get an existing solution to a minimum amount of characters. So you start to think about, okay, how can I improve this in size? And if you read the specs for the game of life, then you see, okay, there is a definition for living cells and dead cells, but in the end, you only can focus on like one kind of them and reduce it to this. So you only check if a cell has 3 neighbors, then it's still alive, and if it's alive and has 2 neighbors, then it's also alive. Otherwise, it's dead. So quite easy. And if you then use ternary and binary operation, then you can write it in one line. So it's still the same code, but what a bit more modified. And first thing that you usually do is to replace long variable names with single characters. So it's like this. Then we can like compress it a bit and can get rid of the brackets. And as we deal with numbers only, we can use binary operators instead of logical AND and OR. So it's like this. And if you compress this again, it's only like 19 bytes to write the whole logic that like cares about the next generation. To explain you the code a bit more, you see there's a body with an ID. Most people don't know, so if you have a named ID, in the HTML you can access it without saying document get element by ID because it's available there in the scope. Then we have an onload handler, so this is like the whole code that's in there. It doesn't have quotes around because there's no space, so we can save 2 quotes characters by just making sure that there's no space in the code. And we have an interval that runs like almost every 100 milliseconds. And this code is to generate the first pattern that's visible. It's more like a pseudo-random generator. This code will run through all the cells. And the next code will like check the amount of neighbors that every cell has. And then this is the main code that we saw before. So this is to check or to decide if the next cell will live or die. And we also need to output the whole thing. So we use s.inner.html and assign some Unicode sequences with a block and a small thing to make sure that's all the same width. Yeah, that's it. So that's the whole thing you need. If you go back to the code, then we like have the question, okay, how can we hide this invisible code inside of JavaScript? And I thought there's an easy way to do it by using like spaces and new line characters and all this like white space characters that you have. So form feed can be used, and this is like the first page of the ASCII set. And the problem here is that it still needs some space. So if you have an empty, if you have a line break or a tab, then it will like still use something. So you will actually see that there's something going on in the code. What's more interesting is then the next page. So this is the next ASCII character codes, and you see there are a lot of device control characters and file separators and stuff like this. And the cool thing about these characters is that they are not visible because they don't take up any space. So you can combine them and like put them into a string, but they won't like extend this, which was quite cool. So to explain you what's going on, we have this escape thing. Then we have a replace. So because we use hexadecimal values, we only want to focus on the last digit here. So it will replace, it will take the 3rd and 6th characters and join them together, and then add a \n to it. So to explain you a bit more, so these are the characters that we have. The ASCII codes would be on the second page. If we use some more, not random, but things that we want to use, we can then call escape. So it looks like this. You have this strange person sign going on. And we get rid of the person sign and the 1, because we only want to focus on the changing numbers. And then we combine them in groups by 2. We put a \x before them, and then we again have a lot 1. So it's crazy, I know. But it's getting more crazy. I'm sorry. Because I usually develop with Chrome. And when I opened this up in Firefox, I found this thing. It's called mods control character visibility visible. So the whole thing was useless because instead of seeing this, you see actually the hex codes after like 2 weeks of work. Because someone within Mozilla, some people like the idea of displaying control characters. And I thought, oof, shit, what should I do? But I was pretty sure there's another way, and I got an invitation to a conference in Tel Aviv. So they did the first international front-end conference. And I thought, okay, let's do a project Aleph. And so I picked up this symbol because it's quite interesting. I was like interested in different writing systems. So if you ask Hebrew people, like, what is this about? And it's funny because it's not only a letter, so it's not like the A. What's the first character? A. So it's not A only, but it also has the meaning of number 1. So it's like a character and a number. Super interesting. And there's also something called the Kabbalah. I'm not sure if you know this, but it's like more esoteric things, and they're focusing on the meaning of everything. So the meaning of the Aleph is the origin of the universe, and it's also the meaning of like one character or one symbol or one number that contains all the other numbers. So it's like a singularity in some kind of way. And this was like the idea that leads me to the next project. And this is the source code. And if you look on the top, you see some strange Aleph things going on. So you have to read again from right to left. So Aleph is assigned to Aleph with some strange things going on. And if you open this, it's still like the Conway's game of life. So the idea was to have the whole universe being generated out of a single character. And the solution for this mods control character visibility was to get rid of like half of the set that we have. So we have now only 8 characters to use. And I found some interesting characters in the higher Unicode level, so starting from 144 to 1447. And if you look at these characters, they look like this. And if you scale up a bit, you see they have a strange form. And these characters are called chants or cantillation marks, and they are used for rhythmic speaking of the Bible. So they are used in the Hebrew alphabet to put on top of like siblings to say how you, or to define how you speak it in a rhythmic form. And the interesting thing is that they act like surrogates. So they don't take up any space by itself, but they're always like going to the previous characters. So when you write like multiple of them, they're all like in one place. And what I did is like defining the Aleph and then like combine the whole code with the same aspects as I showed before and combine them all in one single character. Yeah, and this was Project Aleph. That's the URL. And you can also like type in Aleph to get a redirect. Yeah. 7 minutes left. Oh, I have to hurry up. Sorry. So that was the project. I'm going to skip this. I was looking for some inspiration, and I came across the Braille alphabet. And this is like, it has like different systems. So one system, like that one, is using 2 by 3 rows. So 2 columns by 3 rows, and I have like 6 different dots in there, but there's also a system where you have like 8 dots. And if you translate this, then it will give you back Mona Lisa, for sure. I hope so. Yeah, it's correct? Okay, good. So what I thought, okay, let's draw a painting and let's be a kind of artist now. And I looked up for the Mona Lisa painting, if you download it from Wikipedia, I think, then the JPEG will be 400 kilobyte. And I said, okay, how can we squeeze it? What's like the minimum amount of bytes that we need to get this into a browser? And an easy way to like shrink the file size would be to resize it. So if we get it to a smaller size that's still like visible, it's only 2 kilobytes. If you would use a GIF, then it's only 440 bytes. And if you get rid of this like random patterns there and clean it up a bit, then it's only like 253 bytes. But I looked at it and thought, okay, it's a nice way of like reducing stuff, but in the end, it's not what I want. So I got back a step and use a really high compression for JPEGs. And if you do this, then you end up with like 2 kilobytes of data for this. But I always try to keep it like below 1K or like 512 bytes. So I was looking for something else, and I found that the WebP codec will save again like half of the file size. And if you play around with the command line arguments, you can get it down to a 244 byte. It looks a bit ugly, but it's still possible to get it down really to a minimum. And if you look at the like original size, if you don't scale it up, then it's still like visible. So you still get the idea that it's the Mona Lisa. And if you open this up in the browser, say a few source, then you will see this. But this is like the image itself. And what I usually do is try to create an HTML page or JavaScript that's some kind of crazy. And I thought about this. And I set up a website that once you load it, will look like this. So it's kind of like a canvas built out of various characters that are totally filled. And the painting, it's like painting. So over time, it evolves. So you see the outline of the Mona Lisa. So it's getting clear, and it's the same as a painting or photography. It also disappears after some time, so it will go away. So this is like the painting I wanted to do. And the whole thing is 500 bytes. And the idea here was to use break characters. So I used this 8 dots break characters. And you can turn dots on and off to get this thing. And actually, you can use like different characters and map them to dots. And the source code for the whole project is this. It looks a bit crazy. Because when you try to find the HTML, you have to start here. And you see there's a canvas, a body, and an image. And the canvas has an ID, the body has an ID, and then there's an image with an onload handler. And the image source points to a hash. And as this is an HTML, the hash will reference to the same document. So what it does, it loads the HTML or this page into the image, and this will interpret the first part. The first part, as you see, it's a WebP, and it's like the image that you want to display, and it stops after some time because it's done. There's no more like pixel to draw, so it will ignore the following lines. And then the onload handler is called, and it's quite easy in the end because it gets the context from the canvas, it draws the image, and then it loops over an interval and updates the inner HTML of the pre-tag with some data it gets from the image. Yeah, that's it. You can look this up on m1k/Mona, and it's the first time I show this, so you're the first one who will tweet it. I'm happy to get your feedback on this. I have 2 minutes left. Yeah, is it correct? So I try to answer some questions, and this is maybe the first question you will ask me. Why? So first aspect, it's fun. So it's totally fun to work on this kind of projects. You can create something by your own, and that's the second argument. You can use your own creativity to like draw things, create games, and do something new. But it's also good to find or to set your own limits. So you limit yourself by a specific size. You have to force yourself to like be more efficient and to learn new things and new hacks to get it done in this amount of bytes or characters. Another thing is that it helps me to focus on ideas. So when I ever pick up an idea, for example, this Pac-Man game, the main work was, okay, what is the minimum amount of things that I have to do to make this work? So I need a maze, I have to put in some coins and a character that moves and a ghost, and that's it. We don't need colors, we don't need more than one ghost, we don't need really high artificial intelligence, but it's like a good way to learn how to focus on problems. And it also helps me in the end to structure my code, also for my daily projects I do at work. So the output looks totally scrambled, but when I write the project, it's always super intended. Everything is well commented, and there are just some preprocessors that will like erase all the white space and so on. And one thing that I like about this kind of project is the community. So you might have seen many of these demo scene projects from the 80s, and they were always super close. So no one wanted to share their super secret hacks. And now that we are working on the web, and now that we're using JavaScript, everyone is super open. So I'm presenting stuff like this. There are people writing blog posts. Everyone is open sourcing their tools, and it's really nice to get this kind of feedback. And I have to thank many people, and I'm super happy that Subsess is here, over there. Yeah, he's one of the best guys. So whenever I think I'm done and send a tweet on Twitter, he comes and say, okay, let's change this to save 10 more bytes, stuff like this. But it's also the other way around, you said. So it's always like, it's good to have new perspective from outside and new ideas and clear heads to look at this kind of projects and code, and it will help you out. Yeah. So I'd say it's now up to you to do this kind of project, because I think it really helps you to be a better developer, because you have to be curious about new things and you have to force yourself with these limits. And yeah, there are different projects. JS1K is a competition. I think it's twice a year. There's a project, 140 bytes. It's not active anymore, but they have a wiki on GitHub with all the hacks that you can use. There's also Pods. It's an alt site where they do any kind of demo scene, not only web-related, but also like Atari and Amiga and so on. And there's Shaderto. There's something new. This is not about like size. It's more about web shaders and visual aspects. And yeah, that's it. So go out, create something, and I say thanks.